in this video, we're going to determine the vertical and horizontal components as well as the tension in the wire or the rope, anything of this kind. So how we're going to proceed is as follows. We have been given this beam which weighs 150 newtons, of which we know that the center of mass is actually in the middle. So it is actually in the middle. So we have 1.8 meters. So the weight is actually in the middle here. And so the distance that is going to be covered, or rather the distance that we're going to consider is 1.8 divided by 2. So for this one, because it is acting in the middle. Now, from this point, we are going to proceed as follows. We want to find, first let's find the tension. We're going to find the tension, of which we know that this one, it is at an angle. So since this is at an angle, there are two possible ways. In fact, if we want, we can find this angle by simply subtracting this from 90, so that it is 90 minus 30. Okay, 90 minus 30, so we are going to have 60. So if we want, we can write t cos 60 here, or t sine 30. So now let me try to explain a little bit how we are going to proceed. So these are the two possible ways. So we have this scenario where we have something like this. If we have an angle here, so the vertical component is this one and the horizontal component is this one. Now, using the concept of Sohcahtoa, we have Sohcahtoa. So we have the sine is equal to opposite over hypotenuse. So we have this one. So let's call this one y. And if this, okay, let's call this one as t, as given in the question here. So our sine theta here, will be equal to, so the opposite, which is y over t. So our y will be the t sine theta. So this one, it is t sine theta. So this one, this component and this component, they are the same. So this component here and also this one that is going to be here, they are the same. So this one and this one, they are the same. Just like this component and this component are also equal. So how we are going to proceed is like this. Let me just erase this part now. Okay, so here where the theta is actually 30 degrees. Okay, so we are going to take the moment from this point here. So taking the moment from this point, so we are going to say the clockwise moment must be equal to anti-clockwise moment. So the clockwise moment, it actually goes like this in the clockwise direction. Okay, going in the clockwise direction. One that is called the clockwise moment. So those moments that act, or rather that take the direction of the clock, are called the clockwise moments. And then the anti-clockwise, it is simply the opposite, which goes like this, counterclockwise, in other words. So from here, what we're going to do is we are going to take the moment. So from here, we are going to take the moment from here. So from here, we have how many forces? We have one, which is the weight one, and then we have this one, the tension, sine theta, and also this one. So what we're going to do is we have this one. So from this to this, we have, so this is the weight of the beam. So we have the F, okay, the F1, which is the weight. So this is the weight, 1 times the distance. Moment is force times perpendicular distance from the line of action. So the line of action that we're going to consider here is this one. So the distance that we're going to consider is the total distance, or rather the total length of the beam. Then we simply divide by 2 because weight is concentrated right in the middle. So from here, we are going to say 1.8 meters over 2 in the middle, plus the weight number 2, or this one, the weight that is hung right at the end of the beam. So this is weight 2 times z. So the distance 2 is from this to this, which is 1.8 meters. So from here, what we're going to do is, so these are the forces that are acting in the clockwise direction. Okay, then we also have the other one, which is this one, which is actually, okay, in the other direction, which is, so the force here we have the t sine theta, that is the force that we've been given, times the perpendicular distance. So from here to here, what we've been given is 1.4. So times 1.4 meters. So this one is just like yeah, like this, as simple as this. So from here, what we need to do is we just need to plug in the values, and what we're going to get is an answer for this one. So let's plug in the values. We have 150 for weight 1, which is the weight of the beam, and this one we have 1.8 meters over 2, plus the weight 2, which is 250 newtons, times 1.8 meters is equal to the t sine 30 degrees times 1.4 meters. So from here, what we're going to get is when, so this one and into this one, we're going to have 75 newtons here. And then this one, if we multiply, this one times, okay, this one and this one we multiply, then we add it to this. What we're going to have is, okay, what we're going to have is 585. So 585 newtons. Okay, so here we are going to equate to this one. T sine 30 is just 0.5 or half. Then times this, what we're going to get is 0.7t. So from here, we can simply divide by 0.7. So if we divide by 0.7 here, so t is equal to 585 divided by 0.7. We are going to get 835.7 newtons. So this is the value for the tension, for this tension. So this is the value. Now let's proceed to find the vertical and horizontal components. So we are going to begin with the horizontal component, then the vertical at the end. So we know that the summation of forces in X must give us a 0. So from here we have this one, which is the force, the vertical, or rather the horizontal component, which is going in this direction, in the positive direction. So we have FH. Then we have this one. So if this is T sine theta, then we have this one that is going to be T cos theta. So this one, it is the horizontal component of this force. So it is in this direction, which is actually the same as this direction. So we have minus T cos theta. This must give us a 0. So our FH will give us, when this crosses the equal sign, what we're going to have is T cos theta. So from here, we can just plug in the value for this. So we have 835.7 newtons cos 30 degrees. So from here, what we're going to have is 723.7 newtons as the horizontal component of the force. And now from here we're going to proceed to find the vertical component. So we again know that the summation of forces in Y must give us 0. So here we have this one, which is the vertical component, which is the vertical component of the force. Then we also have, okay, these that are pointing upwards. We have this one, and then we have this one, which is the T sine theta, so upwards, T sine theta. Then we have this one pointing downwards, so minus W1, which is the wet one. Then minus, this one is also pointing in the downward direction. So W2, which must give us a 0. So if we make this FV the subject of the formula, since it's the one we are looking for, we are going to have FV is equal to, when this one crosses the equal sign and this one crosses the equal sign, what we're going to have is wet 1 plus wet 2 minus T sine 30 degrees. Okay, yes. So for all these, we have 150 newtons for the weight of the beam, plus 250 the weight, okay, which is W2, this one, then minus 835.7, then sine 30, sine 30. So here what we're going to have is, when we add this and this, okay, 150 plus 250 minus 835.7 sine 30, what we're going to have is negative 17.5 newtons.